All right, this is homework chapter 4, part 2. We're going to start with problem number 65. You got your street light hanging from 2 cables, and we are asked to find the tension in each cable. A 100 kilogram street lamp is supported equally by 2 ropes as shown in figure 443. So it's symmetric, which is pretty great. Here's this. This is 40 degrees and that's 40 degrees. And find the tension in each rope. All right. How we solve these, we sum of the forces in the X, sum of the forces in the Y. So sum of the forces in the X equal 0 because they cancel each other out. So T, we'll call that T1. We'll call this 1 and 2. And we're fine. T1 sub X plus T2 sub X equals 0. All right, we'll give a T1 a negative T because it's going in the left direction. T1 cos 40 plus T2 is positive, cos 40 equals 0. So these cos 40s will cancel. So T1 equals T2. And we kind of know that because it's symmetric, right? So we know the tension's got to be equal and opposite. All right. So sum of the forces in the Y equal T1 sine 40 plus T2 sine 40 equals mg, right? It's supporting that weight there, and mg is 100 kilograms. So T1 plus T2 equals 100 kgs over times 9.8 meters per second squared divided by sine 40. And T1 equals T2. So we'll do this T1. So this is, now we'll take 2 T1 equals that. And I'm take the 2 off, equals this. I'll divide both sides by 2, sine 40, sorry. And my answer is going to be 762 newtons. So what I just did here was I took this and I knew it was equal to T1. I just substituted it. And I got 2 T1 equals that. Then I divided both sides by 2. All right. That was number 65. Okay, problem 81. 81. We've got 2 masses on inclines. And this is 60 degrees. And this, and I know it looks equivalent, and that's 25 degrees. And we know that, let's see, which one, M1, I'm assuming M1 is this guy, 6 kgs. And we need to find out the mass of that block, M2, and so that this system will be in equilibrium and the force will be 0. Okay. So I know that I am being held in place by gravity alone. And so gravity obviously goes this way. So I need to set my vertical components of each block to each other. So I have a system in equilibrium. Okay, so I have 6 kgs times, this is 60 sine 60 is going to equal M2 times sine 25. So now I've set because I have no forces in the horizontal direction. I just have to figure out what they're going to be in the vertical direction. So this is easy enough to solve. M2 equals 6 kgs sine 60 divided by sine 25. And my answer is going to be 12.3 kilograms. And that's the answer to 81. And, you know, I know that I go through these relatively fast, but sometimes when you're learning this stuff, you may want to practice a few times. Practice and make sure that you consider each step and you understand everything. So let me pause and I'll move on to the next. Okay, for number 85, it says a 30 kilogram golden retriever stands on a digital scale. If the dog and scale are positioned in an elevator, calculate the weight of the dog when the elevator accelerates at 3.5 meters per second downward, when the elevator cruises down at a steady speed, and when the elevator accelerates up at 4 meters per second. All right, so it may seem counterintuitive, but when the elevator accelerates down, there's less force. So we have 30 kilograms, and you could 30 kilograms times 9.8 meters per second squared minus 3.5 meters per second squared. And that's going to give us, let's see, 189 newtons. All right, so that's because when it goes down, there's less force on that surface, right? When the elevator goes upward, it pushes up and causes you to push down harder. It's Newton's third law. Okay, now at a constant velocity, the elevator adds nothing to it. So it's going to be 30 kilograms, and it's only going to be that weight, 9.8 meters per second squared. And that's going to give us 294 newtons. And then when it goes upward, the elevator pushes on you and you push down on it. So you have to add those, the weight and the acceleration. So 30 kgs, 9.8 meters per second squared, plus 3.5 meters per second squared. And we are going to get 414 newtons. All right. And that is the elevator problem. And it's very counterintuitive, but go on an elevator and see if when it accelerates upward, if you don't feel heavier. That would be a good way to find out, to prove it to yourself.